Hey class, this is Mr. Robert, Shasta High School, and we're going to look at the first homework assignment in Chapter 2. Question number 6 says, a tile pattern has 5 tiles in figure 0. That is kind of an important piece of information. So it starts out with 5 tiles in figure 0, and it adds 7 tiles every single time it grows up. Now, if I was to look at that, that's a situation, right? If I was to look at that as a table of values, for example, I know that it said it starts with 5 tiles. Yeah, 5 tiles. So I could say figure 0 starts with 5 tiles. Figure 1, it says it adds 7 tiles each time, so it's next is going to go to 12. Figure 2, if I 12 plus 7 would be like the 19, right? 7, 8, 9. And then the third tile should have 19 plus 7 more, so that should be like the 26, I believe. So what's happening here is every single time the figure figure, or we could call this x, right? Every single time x increases by 1 unit plus 1 unit, my y values are increasing by plus 7 units. So these are the y's, or the number of tiles in this situation. So my equation here, right, would look something like y is equal to, we are growing by 7 tiles, so 7x, plus our 0th term starts out with 5 tiles. And now that I write this down, an important thing to do is kind of consider these values and see if this equation is producing the correct results. And yeah, when I put 0 into that, this term is gone, right? 7 times 0 is 0, and it gives me 5. If I put in 1, it becomes 7 plus 5, which is 12. If it's 2, it becomes 14 plus 5, which is 19. 3 is 21 plus 5 is 26. So because this equation is producing all the correct outputs, we'd say this is the equation, right? Y equals 7x plus 5. Let's look at question number 7. Benjamin is taking Algebra 1 and is stuck on the problem shown below. Examine his work so far and help him by showing and explaining the remaining steps. So the original problem was to simplify 3 times a to the negative second times b, and then that entire expression is raised to the third power. So it says he knows that if you have this thing, right, being raised to the third power, it's 1, 2, 3 copies of those factors. So now what? Well, if I look at this, this is all multiplication, right? And I could reorder some of the factors so maybe it would look better. So I've got 3 factors of 3. Whoop, get back up here. So that would look like a 3 times a 3 times a 3. The next thing I've got is a to the negative second. And I've got that 3 times. I've got a to the negative second, a to the negative second, a to the negative second, which would be a to the negative 6th power, right? That's not a 9. It kind of look like it. It's a to the negative 6th. And then the last thing I have are 3 factors of b, b, so I'll write b to the 3rd. Now, one of the things that we do not do, it says he's stuck on, well, one of the things that we don't like to do are leave negative exponents. So I'm going to do 2 things. First of all, I'm going to go ahead and rewrite this, replacing 3 times 3 times 3 with that product. So I've got 27 a to the negative 6 b to the 3rd. Now we've already seen how if I have a giant 1 in a monomial like this, I can bring that out to simplify it. One of the things I can also do is I can also multiply by 1. It is a fact, right? It's called the multiplicative identity, that if you take anything, I don't care what it is, say it's a magic box, and you multiply it by the number 1, right, it stays the same. It's still the magic box. So anything times 1 is itself. Well, I can use that by multiplying. I can use this fact and multiply this expression by a number 1. Another fact is that, so here's the thing. It's like, what number 1? What giant 1 do you want to multiply it by, Mr. Roberts? I want to multiply it by a to the 6th power over a to the 6th power. Now you can look at it and say, yeah, you're right. That is the number 1. A to the 6th over a to the 6th, right, is equal to 1. But how in the world does that help us? Well, what happens is now when I've got this a to the negative 6 and I multiply it by a to the positive 6, that becomes a to the 0 power. And you may be thinking, what? How is that possible? Remember, anytime, if I've got x cubed times x squared, that's 5 factors of x. Think about what I'm doing. I'm adding the 3 and I'm adding the 2 and I'm getting x to the 5th. So I'm adding the 3 and 2. Well, if I add over here this negative 6, right, and this negative 6, I get a to the 0 power. So this becomes, quite magically, actually just algebraically, 26, or 27 rather, times a to the 0 power times b to the 3rd over a to the 6th power, because there's now an a to the 6th down at the bottom. And then as a final step, we're just going to point out, hey, this a to the 6th, I mean a to the 0, do you know what that is? That's just the number 1. So that means my final simplified answer is going to be 27 times b to the 3rd over a to the 6th power. And again, this was simplified by just introducing this special giant 1, a to the 6th over a to the 6th. All right, let's move on to question 8. There it is, 8. It says, examine the function h of x to find it right, then estimate the values that are shown. So we're going to look at a couple of these. We're going to first of all look at h of 1. So if I look at this function, if I was to place x as 1 into it, the question is, what output does it produce? And you can see right here, this is the number 1. So I just and you can see it's producing this value that's right about here. The question is, what number is that? Well, it looks like it's 1, 2, right? So it looks like when I take the function h and I put 1 into it, it's giving me an output value of 2, right? H of 1 produces 2. And it doesn't produce anything else, right? There's not any other value above or below that. H of 1 just produces the number 2. What's the other one they asked? They asked, what is H of 3? Okay, H of 3. This time I'll use this. Let me make this a I guess I'll just use this pen. So I'm here at 3, so I'm looking at these values and I just go down, 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 down. And you can see right around here, it looks like, if I was to draw this horizontal dash line, it looks like it's meeting right around there. So it appears to me that when h is 3, I'm sorry, when x is 3, right, when I put 3 into this function, when x is 3, it appears that it's giving me an output of negative 3. So when x is 3, I'm getting negative 3. Kind of difficult to see, especially in this really grainy picture, but sure enough, if you do, oh, the other thing I forgot is I have my beautiful ruler tool. There it is. There's the ruler. Look at that. And you know, I could take the ruler tool, I could take this orange pen, I'll make it very thin. So here's like the thinnest of orange lines. And then I can see right here, ooh, that's interesting. Was that really, let me do that again because I could be totally off. I'm going to make this line, yeah, there you go, nice and vertical, and I just bring it over here to h of 3. I'll draw the line right through it. And then I'm going to take this horizontal line. You know, I don't know. It could be, let's see, this should be at 0 degrees. It could be, yeah. It's my crazy glasses or something. No, it looks like it. No, it doesn't look like that at all, does it? It looks like it's somewhere below it. So if I was doing this, right, to me, it's somewhere below negative 3. It appears that it's somewhere between negative 3 and negative 4. So I'm going to hedge my bets, and I'm going to say, well, it's probably not exactly at negative 3, so I'm going to say between negative 3 and negative 4. So maybe I'm just having difficulty following those lines, because those orange lines look suspicious to me. But it looks like it was below negative 3. All right, the next value, it said, what about h? Ooh, what is x when h of x is 0? Oh, okay, so this is a different question. So this function appears to be 0 a lot. In fact, if you look at it, it looks like it's 0 here, it's 0 here, it's 0 here. So I'm just picking those x values that are producing outputs of 0. And you can see there's 4 of them there, right? So it appears -3, -4. There's a lot. I would say, let's say, x can be, it looks like -4, -5. It could be -2. It looks like 0 produces 0, and it looks like 2 produces 0, right? So there's 4 values there, -5, -2, 0, and 2, that all produce answers of 0. And then the final question is, nope, 2 more, h of -1 and then h of -4. So h of -1, right, if I put in -1 into this function, it looks like it's producing an output of, I'm going to say -2. So it looks like h of -1 produces an output of -2. And then h of -4, -4, ooh, that's a fairly large number, isn't it? So, wow, so it's up here somewhere. And I'm going to say it's around, 12. That seems reasonable. So h of -4, when I put -4 in, this function's giving me 12 back. So there we go. That is the third question in this homework assignment. My answers were h of 1 is 2, h of 3 is somewhere between -3 and 4. The values of x is -5, -2, 0, and 2 all produce outputs of 0. H of -1 is -2, and h of -4 looks like it produces an answer of 12. All right, next it says calculate the value of each of the following expressions. Oh, that's nice. So just kind of a nice little simple order of operation trip down memory lane. In my numerator, I do have some exponentiation, so that is going to become a 6 times 49. That denominator has 2 different terms, but I can rewrite it so it looks like a factor of 6, right? There's no plus in there now. That's nice. Well, I do have this plus 11 over here, but if I just look at the first term, 6 times 49 over 6, that is clearly a giant 1. So I end up with 49 plus 11, which is 50, 60. I believe this first one is 60 units. And I know this is ridiculous, but I'm going to double check myself here. 9 plus 1 is 10, 4, 5, and 6. I get 60. Yeah, that's nice. Okay, next one. I've got 5. 5 raised to the power of 3. 1 plus 2 is 3. So I've got to evaluate those those parentheses. That's the number 3. So this is 5 to the 3rd power, and then I'm going to add 8 and subtract 6. I can combine these right now. An 8 and a -6 is going to be a plus 2. So this is going to be 5 cubed plus 2. 5 cubed, let's see, 5 squared is 25. And if I take 25 and multiply it by another 5, I should get 125. So this becomes 125 plus 2, which is 127. You know where to find me if I'm wrong. And then the last one here is, let's see. I've got to do this exponentiation, right? I've got to square these, and then I can combine them, and then I can take the square root. This square root symbol is a grouping symbol in and of itself, so that means I've got to figure out what that is before I subtract 5. So let's go ahead and square these numbers. I've got 3 squared, which is 9, plus 4 squared. 4 squared is 16, and then I'm going to take the square root of that sum and then take away 5. So let's go ahead and add 16 and 9. 16 and 4 is 20, and then 5 more is 25. This is the square root of 25, take away a 5. The square root of 25? Are you kidding? That's 5. And 5 minus 5 is 0. So my answers there in this order are 60, 127, and then part C is 0. All right, let's go to 10. 10 says, examine the diagram at right. Based on the information in the diagram, which angles can you determine, or which angles can you use to determine the measure? Which angles can you determine the measures of? Oh, okay, okay, okay. Copy your diagram on paper and determine the measure of only angles that you can justify. All right, so when I look at this, I'm not, there's a lot of angles there. I think there's like, what, there's 1, 2, 3, 4, 8, 9, 10, 11, 12, 13, 14. There's 16 angles there, and I don't think I can figure out all of those angles, but I can certainly figure out some. In fact, one of the first ones I'm going to write down is that this angle is 74. Not 75. This angle is 74 degrees because it's a vertical angle with this other one. These two angles, these vertical angles, are congruent. The other thing that I know is that linear pairs have to add up to 180. That makes me able to think about this angle here with the smiley face. And I know that that angle that's smiley plus the 74 has to add up to 180. So why am I doing it a smiley? Let's call it x. So if I say 74 degrees plus some angle x has to equal 180, that means x has to equal 180 minus 74. I'm stacking them. So 10 minus 4 is 6. I borrowed one. So now I got 7 minus 7 is 0. And then I got the 1 minus nothing is 1. So I get 106. 106 plus 74 is 180. So this angle x right here, this one, is 106 degrees. Because linear pairs, write that down, linear pairs are supplementary. Linear pairs are supplements. So this has to be 106 also because it is a vertical angle. Now, the other ones I know about, and this is because I've got these parallel lines, right? Because this line and this line are parallel to each other, I can talk about these corresponding angles. So I know that this angle is 106, 106 because it's corresponding. This angle is 74 because it corresponds with this angle, right? That's corresponding means. This angle right here corresponds with this one, so they're both 74. And the other corresponding angle is this one right here, has to be 106. So that's where I'm at. I can't say anything else about any of these angles over here. I just put a sad face. And the reason why I can't is because I don't know that these lines are parallel to each other. It doesn't show that. So I can figure out those 8 angles. 4 of them are 106 and 4 of them are 74 degrees. And I believe that, yeah, that is the very last question in that beautiful, beautiful homework assignment.